Why, hello there, lovely one. We're busy working through questions, trick questions that you can find in the IEB Paper 2, November 2017. And this particular question, I think, came from question 4. Sorry, it didn't. It came from question 3. So it is question 3b. As we can see that it is an identity question. It asks us to prove that that thing over there is equals to that thing over there. Before we even start talking about it, let's do this. And this is extremely important to the whole proof. We have to divide it up into the two different sides. It is possible to work with both sides at the same time, but you can't work with them as if it was an equation. You have to work with it as an expression so you can then get both sides to look the same. Okay. So the kinds of things they're looking to test in questions like this are your compound angle identities. So let's just compound angle identities. We'll be lazy and write ID. We also have double angle identities. Double blah blah blah. Then we also have the quotient identity, which is the sine of theta over cos of theta equals tan of theta. And then of course we have our favorite one. 1 is equals to sine squared theta plus cos squared theta. These two are not on your information sheet, so you must know them off by heart. The other ones, they are on your information sheet, but you should still try and know them as well as you can. Oh, and the one other thing that sometimes comes up are your co-ratios. So cos theta is equals to sine of 90 minus theta. So those do sometimes come up with these kinds of questions, but I'm pretty sure in this one it doesn't come up. Before you even try to attempt it, you need to be looking for clues within it. So I'm going to bring up my highlighter and let's see. The first thing I see going from left to right is that I've got a double angle identity. So I'm going to be looking over there for double angles. I've also got a double angle over there. So once again, I'm looking for those. What I don't see anywhere is tan. So I'm actually going to cross that all out because yes, why not? I also don't see 1, which means I'm probably not going to use the 1 equals blah blah blah. But I'm going to leave that option open for now. I'm also going to leave the compound angle open for now, and I'll show you why. This might turn into something interesting just now. And now the other question that comes up is, how do I know which side to work with? Do I work with the left side or the right hand side? It's always easier to work with the side that looks the most complicated because you can do the most with it. Generally, that is the left hand side. Now, I tend to move through these questions quite carefully and slowly by only changing one thing at a time. And the first thing I'm going to change is the denominator of the first fraction because that's what popped out to me the soonest. And that is the identity that becomes 2 sine, and let's make it theta because that's what it is, cos of theta. I can then cancel this cos of theta with that cos of theta, which works out really well for me because, of course, if we're going to add or subtract any fractions, we need to have a common denominator. So before I move any further, I'm going to put everything over a common denominator so that I have 1 minus cos 2 theta, and it's going to be over 2 sine theta. Obviously, I can't cancel anything at the moment, especially because it's 2 terms at the top. So I need to start looking for clues with this cos 2 theta. I know it's a double angle, so I'm going to look at my formula sheet and change to one of the other double angle varieties. Just to make my life easier, I'm going to first put everything else down so that I don't get it confused along the way. And I'm going to put brackets around the place where cos of 2 theta was. I am looking for, or trying to get to a point where I've just got to get sine theta, and that's why I've chosen this value of that same identity. And you'll see magic now. Of course, I'm going to be multiplying out the brackets, so it's 1 minus and then it's plus 2 sine squared theta. I don't necessarily have to show this step. The reason I'm showing it is because I'm a teacher, and it's a good idea so that you can follow my thoughts. The other step I'm about to show is, instead of writing sine squared theta, I'm going to write sine theta times sine theta over 2 sine theta. And once again, that's because I'm a teacher, and I want to make it obvious that when I am dividing by those numbers, they cross off nicely. Sometimes it's difficult to see when it's just the sine squared theta. So there we go. And of course, that was the right-hand side. So we have got where we wanted to get to. In the end, this question was actually only asking about double angle identities. And these questions you can get good at by doing that wonderful thing called practicing. It's really, really important because you start to see things that pop up everywhere. Common type of problems. Okay, with that, it's enough for me. Much love.